Hello everyone, my name is Abul Hassan Momin. I am pursuing BTech from Alia University in the Department of Civil Engineering. Today I will discuss about bricks. Bricks. Bricks are the most commonly used construction material. The bricks being durable, strong, reliable, low in cost and easily manufacturable anywhere. They are extensively used all over the world. The bricks are obtained by molding clay in rectangular blocks of uniform size and then by drying and burning these blocks. Size and shape specification. Bureau of Indian Standard has recommended the standard size of the bricks as 19 into 9 into 9 semi. With mortar thickness, the size of such bricks becomes 20 into 10 into 10 semi, which is also known as the nominal size of the modular bricks. The minimum compressive strength of the standard bricks has been specified as 35 kg per square semi. However, different state PWDs have adopted different size. Frog. A frog is depression in on bearing face of a molded or pressed brick. The frog reduces the weight of the brick and makes it easier to remove from the forms. Frogs greater than 3 by 8 inch deep at any point are treated the same as cores. Frogs less than 3 by 8 inch deep don't affect the net area of the unit. The bricks containing frogs should be laid with the frog up so that the frog is completely filled with mortar. Constitution of good brick art. In order to get a good quality bricks, the brick art should contain the following constituents. Silica. A good brick art should contain about 50 to 60% of silica. The presence of this constituent prevents cracking, shrinking and warping of raw bricks and thus imparts uniform shape to the bricks. The durability of bricks depends on the proper proportion of silica in brick art. The excess amount of silica destroys cohesion between particles and the bricks become brittle. Alumina. It is the predominant constituent of all kinds of clay. A good brick art should contain about 20% to 30% of alumina. Alumina imparts plasticity to the art so that it can be molded. Higher contents of alumina cause raw bricks to shrink and warp during drying and burning and become too hard when burnt. Lime. A small amount of lime, not exceeding 5%, is useful in good brick art. The lime should be present in a very finely powdered form only because even small particles cause flaking of the bricks. The lime resists shrinkage of raw bricks. The sand alone is infusible, but it slightly fuses at kiln temperature in the presence of lime. Such fused sand acts as a hard cementing material for brick particles. The excess of lime causes the brick to melt and hence its shape is lost. Iron oxide. A small amount of iron oxide, the extent of about 5%, is desirable is good brick art. Like lime, it helps sand to fuse. It also imparts red color to the bricks. If the content of this constituent is less, the bricks would be yellowish in color. Magnesia. A small quantity of magnesia in brick art develops yellow tint to the bricks and decreases shrinkage. Excess of magnesia leads to the decay of bricks. Harmful ingredients in brick. Following are the undesirable ingredients in brick art. Lime. A small quantity of lime is required in brick art, but if present in excess, it causes the brick to melt and hence brick lose its shape. Iron pyrites. If iron pyrites are present in brick art, the bricks get crystallized and disintegrated during burning because of the oxidation of the iron pyrites. Alkalis. They are mainly in the form of soda and potash. The alkalis act as a flask in the kiln during burning and they cause bricks to fuse, twist on off and lose shape. Excess of alkalis in brick absorb moisture from the atmosphere, which on evaporation leaves behind grey or white deposits on the brick wall surface and thus spoil the appearance of the building. Pebbles. The presence of pebbles of any kind is undesirable in brick art. They do not allow the clay to be mixed uniformly and thus result in weak and porous bricks. Such bricks also do not break regularly as desired. Vegetation and organic matter. The presence of vegetation and organic matter in rich art helps in burning, but if such matter is not completely burnt, the bricks become porous. This is due to the fact that gases will be evolved during the burning of the carbonaceous matter, which will result in the formation of small rolls. Manufacture of brick. Following consideration if taken care of in the selection of brick field for the manufacture of bricks will help cause economy. On the brick field should be plain ground. The composition of available should be of good quality. The site should be well linked up with the communicating roads so that the materials can be easily conveyed. The required labor should be locally available. The process of manufacturing bricks involves following four distinct operations. 1. Preparation of clay. 2. Molding of bricks. 3. Drying of bricks. 4. Burning of bricks. Preparation of clay. The clay for bricks is prepared in the following order. Unsoiling. The top layer of the soil, about 200 mm in depth, is taken out and thrown away. The clay in top soil is full of impurities and hence it is to be rejected for the purpose of preparing brick. Digging. The clay is then dug out from the ground. It is spread on the leveled ground, just a little deeper than the general level. The height of heaps of clay is about 600 mm to 1000 and 1200 mm. Cleaning. The clay as obtained in the process of digging should be cleaned of stones, pebbles, vegetables, matters. If these particles are in excess, the clay is to be washed and screened. Such a process naturally will prove to be troublesome and expensive. Weathering. The clay is then exposed to atmosphere for softening and mellowing. The period varies from few weeks to full season. Blending. The clay is made loose and any ingredient to be added to it is spread out at its top. The blending indicates intimate or harmonious mixing. Tempering. In the process of tempering, the clay is brought to a proper degree of hardness and it is made fit for the next operation of molding. Kneaded or pressed under the feet of man or kettle. The tempering should be done excessively to obtain homogeneous mass of clay of uniform character. For manufacturing good bricks on a large scale, tempering is done in fug mill. A typical fug mill capable of tempering sufficient earth for a daily output of about 15,000 to 20,000 bricks. A fug mill consists of a conical iron tube with cover at its top. It is fixed on a timber base which is made by fixing two wooden planks at right angle to each other. The bottom of tube is covered except for the hole to take out pugged earth. The diameter of fug mill at bottom is about 800 mm and that at the top is about 1 meter. The provision is made in top cover to place clay inside fug mill. This is the figure of fug mill. Molding. The clay which is prepared as above is then sent for the next operation of molding. Following are two types of molding: on hand molding and machine molding. Hand molding. In a hand molding, the bricks are molded by hand, that is manually. It is adopted where manpower is cheap and is readily available for the manufacturing process of bricks. On a small scale, the molds are rectangular boxes which are open at top and bottom. They may be of wood or steel. The bricks prepared by hand molding are of two types: ground molded and table molded. Ground molded bricks. The ground is first made level and fine sand is sprinkled over it. The mold is dipped in water and placed over the ground. The lump of tempered clay is taken and its dust is the mold. The clay is pressed in the mold in such a way that it fills all the corners of mold. The surplus clay is removed by wooden strike or framed with where a strike is a piece of wood or metal with a sharp edge. It is to be dipped in water every time. The mold is then lifted off and rubbed. It's left on the ground. The mold is dipped in water and it is placed just near the previous brick to prepare another brick. The process is repeated till the ground is covered with raw bricks. The lower faces of ground molded bricks are rough and it is not possible to place frog on such bricks. A frog is marked of depth about 10 mm to 20 mm, which is placed on raw brick during molding. It serves two purposes. One, it indicates the trade name of the manufacturer. Two, in bricks or brickwork, the bricks are laid with frog uppermost. It thus affords a key for mortar when the next brick placed over it. The ground molded bricks of better quality and with frogs on their surface are made by using a pair of pallet boards and a wooden block. This is the figure. Next, table molding bricks. The process of molding of bricks is just similar as above, but in this case, the mold stands near a table size 2 meter into 1 meter. The bricks are molded on the table and sent for further process of drying. However, the efficiency of molder gradually decreases because of standing at some place for a longer duration. The cost of bricks is also increases when table molding is adopted. Machine molding bricks. This type of molding is carried out by two processes on plastic clay machine. Such machine consists of a rectangular opening having length and width is equal to an ordinary bricks. The packed clay is placed in the machine and it comes out through the rectangular opening. This is the machine molding bricks. Dry clay machine molding. In this machine, the strong clay is finally converted into powdered form. A small quantity of water is then added to from a stiff plastic paste. Such paste is placed in mold and pressed by machine to form dry and well-shaped bricks. They do not require the process of drying. Next, drying of bricks. The damp bricks, if burnt, are likely to be cracked and destroyed. Hence, the molded bricks are dried before they are taken for the next operation of burning. For the drying, the bricks are laid longitudinally in the stacks of weight equal to 2 bricks. A stack consists of 10 or 8 tiers. The bricks are laid along and across the stock in alternate layers. While the bricks are placed on edge, the bricks are allowed to dry until the bricks are become leather hard of moisture content about 2%. This is the figure. Next, burning of bricks. Bricks. It is a very important stage in the manufacture of good quality bricks. Burning imparts strength and hardness to the bricks and makes them dense and durable. While the water is removed at the temperature of 650 degrees, but they are burnt at a temperature of about 1100 degrees because the fusing of sand and lime takes place at this temperature and chemical bonding takes between these materials after the temperature is cooled down, resulting in the hard and dense mass. Bricks are not burnt above this temperature because it will result in the melting of the bricks and will result in a distorted shape and a very hard mass when cooled, which will not be workable while bricks can be burnt using the following methods: clamp burning and kiln burning. Clamp burning. Clamp is a temporary structure generally constructed over the ground with a height of about 4 to 6 meters. It is employed when a demand of the bricks is lower scale and when it is not a monsoon season. This is generally trapezoidal in plan, whose shorter edge among the parallel side is below the ground and then the surface raising constantly at about 15 degrees to reach the other parallel edge over the ground. A vertical brick and mud wall is constructed at the lower edge to support the stack of the brick. First layer of fuel is laid as the bottommost layer with the coal, wood and other locally available material like cow dung and husk. Another layer of about 4 to 5 rows of bricks is laid, and then again a fuel layer is laid over it. The thickness of the fuel layer goes on with the height of the clamp. Disadvantages of clamp burning. The disadvantages of clamp burning are this process is very slow and there being no control on regulation of fire breaks of uniform quality are not obtained. Also, most of the bricks lose their regular shape. The bricks near the bottom are overburnt and those near sides and top are underburnt. There are some advantages of clamp burning. The advantages of clamp burnt bricks are saving of fuel, no skilled supervision and labor are required, and burning proves to be economical. Kiln burning. The kilns are used for burning bricks on a very large scale. The kilns may be divided in following two categories: intermittent kiln and continuous kiln. This is the figure of the typical kiln. Kiln burning. The kiln used for burning bricks may be underground, that is Bullstein's kiln, or overground, that is Hoffman kilns. This may be rectangular, circular or oval in shape. When the process of burning bricks is continuous, the kiln is known as continuous kiln. That is Bullstein's and Hoffman's kilns. On the other hand, if the process of burning bricks is discontinuous, the kiln is known as intermittent kiln. Intermittent kiln. The example of this type of an overground rectangular kiln is shown in figure. After loading the kiln, it is fired, cooled and unloaded, and then the next loading is done. Since the wall and sides get cooled during reloading and are to be heated again during next firing, there is wastage of fuel. This is the figure of intermittent kiln. Next, continuous kiln. The example of continuous kiln are Hoffman's kiln and Bullstein's kiln. In a continuous kiln, bricks are stacked in various chambers wherein the bricks undergo different treatments at the same time. When the bricks in one of the chamber is fired, the bricks in the next set of the chamber are dried and preheated, while bricks in the other set of chambers are loaded and in the last are cooled. This is the figure of Hoffman's continuous kiln and Bullstein's kilns. Hoffman's continuous kiln. It is a continuous kiln and has a permanent roof, as a result of which it can function even during rains. The first Hoffman kilns were in the form of a great circular chamber with massive walls and a large chimney at the center, to which underground radial fluids convergent from the inside walls of each of the 12 chambers. The chambers were barrelaged like railway tunnel. When the kiln is in full operation, two chambers will be open and the other 10 scaled up and door and by the interconnecting steel dampers. If the chambers are numbered from 1 to 12, then bricks are being unloaded from 2 and loaded in 1. The chamber is closed between 1 and 12, but opens between all other chambers. Air is drawn through the open door of 2 and through the bricks in 3, 4, 5 and 6, cooling them down and at the same time being heated itself. Chamber 7 is being fired with fuel being fed at intervals through the roof, which is immediately ignited by the hot air from 6. The products of combustion pass on to 8, 9, 10 and 11, drying and preheating the bricks in these chambers. The chambers being loaded and unloaded move forward in sequence, and this way heat is extracted from the cooling bricks and also from the hot combustion gases. Pull strength kiln. In plan, it may be rectangular, circular or oval shaped. The kiln consists of a trench excavated in ground. It may be fully underground or partly projecting above ground. In the latter case, the ramps of earth should be provided on outside walls. The outer and inner walls are constructed from bricks. The openings are provided in the outer walls to act as flow holes. Dampers, which are in form of iron plates, are used to divide the kilns in suitable sections. The bricks are so arranged that all the operations like loading, firing, cooling and unloading run continuously. The bricks are arranged in sections and fuels are formed. The fuel is placed in flues and it is ignited through flue holes. The top of each section being ignited is covered from top with earth and ashes to prevent escape of heat. The flue holes are provided in sufficient number on top to insert fuel when burning is in progress. Generally, two movable iron chimneys are employed to form drug, and they are always placed in advance of section being fired. The hot gases leaving the chimneys warm up the raw bricks. In the next section, each section being fired requires about 1 day to burn. When the section has been burned, the flue holes are closed and it is allowed to cool down gradually. The fire is now advanced to the next section and the chimneys are also moved forward. A tentative arrangement for different sections may be as follows. Section 1 being loaded, section 2 being emptied, section 3 being unloaded, section 4 bricks being cooled, section 5 bricks being burned, section 6 raw loaded bricks being heated to drive out moisture. 2 pairs of chimneys and 2 gangs of workers will be required to operate this kiln. This is the figure of Woolsten's kilns. Two sets of sections are shown in figure. Woolsten's kiln on an oval or circular trench is dug to a long exhaust chimney is made. Green bricks are put in on side. Fuel zone is made for firing bricks. Bricks are taken out from other end. Classification of bricks as per common practice. Bricks which are used in construction works are burnt bricks. They are classified into 4 categories on the basis of its manufacturing and preparation as given below. First class bricks. These bricks are table molded and of standard shape and they are burnt in kiln. The surface and edge of the bricks are sharp, square, smooth and straight. They comply with all the qualities of good bricks. These bricks are used for superior work of permanent nature. Second class bricks. The bricks are ground molded and they are burnt in kiln. These bricks are commonly used at places where brickwork is to be provided with a coat of plaster. Third class brick. These bricks are ground molded and they are burnt in clamps. These bricks are not hard and they have rough surface with irregular and destroyed edges. These bricks give dull sound when struck together. They are used for unimportant and temporary structures and at places where rainfall is not heavy. Fourth class bricks. These are overburnt bricks with irregular shape and dark color. These bricks are used as aggregate for concrete in foundation, floors, roads, it's because of the fact that the overburnt bricks have a compact structure and hence they are sometimes found to be stronger than even the first class bricks. Classification of bricks as per constituent materials. There are various types of bricks used in masonry. Common burnt clay bricks. Common burnt clay bricks are formed by pressing in molds. Then these bricks are dried and fired in a kiln. Common burnt clay bricks are used in general work with no special attractive appearance. When these bricks are used in wall, they require plastering or rendering. Sand lime bricks. Sand lime bricks are made by mixing sand, fly ash and lime followed by a chemical process. During wet mixing, the mix is then molded under pressure, forming the brick. These bricks can offer advantages over clay bricks, such as their color appearance is grey instead of the regular reddish color. Their shape is uniform and present a smoother finish that does not require plastering. These bricks offer excellent strength as a load bearing member. Engineering bricks. Engineering bricks are bricks manufactured at extremely high temperatures, forming a dense and strong bricks, allowing the brick to limit strain and water absorption. Engineering bricks offer excellent load bearing capacity, damp proof characteristics, and chemical resisting properties. Concrete bricks. Concrete bricks are made from solid concrete. Concrete bricks are usually placed in facades, fences, and provide an excellent aesthetic presence. These bricks can be manufactured to provide different colors as pigmented during its production. Fly ash clay bricks. Fly ash clay bricks are manufactured with clay and fly ash at about 1000 degrees Celsius. Some studies have shown that these bricks tend to fail poor produce pop-outs when bricks come into contact with moisture and water, causing the bricks to expand. Test on bricks. To know the quality of bricks, following 7 tests can be performed. In this test, some are performed in laboratory and the results are on field. Compressive strain test. This test is done to know the compressive strength of brick. It is also called crushing strength of brick. Generally, 5 specimens of bricks are taken to a laboratory for testing and tested one by one. In this test, a brick specimen is put on crushing machine and applied pressure till it breaks. The ultimate pressure at which bricks is crushed is taken into account. All 5 brick specimens are tested one by one and average result is taken as bricks compressive or crushing strength. Water absorption test. In these tests, bricks are wetted in dry condition and let them immersed in fresh water for 24 hours. After 24 hours of immersion, those are taken out from water and wiped out with cloth. Then brick is wetted in wet condition. The difference between wets is the water absorbed by brick. The percentage of water absorption is then calculated. The less water absorbed by brick, the greater its quality. Good quality bricks does not absorb more than 20% water of its own weight. Efflorescence test. The presence of alkalis in bricks is harmful and they form a grey or white layer on brick surface by absorbing moisture. To find out the presence of alkalis in bricks, this test is performed. In this test, a brick is immersed in fresh water for 24 hours and then it's taken out from water and allowed to dry in shade. If the wettest layer is not visible on surface, it proves that absence of alkalis in brick. If the whitish layer visible about 10% of brick surface, then the presence of alkalis is in acceptable range. If that is about 50% of surface, then it is moderate. If the alkalis presence is over 50%, then the bricks is severely affected by alkalis. Hardness test. In this test, a scratch is made on brick surface with a hard thing. If that does not leave any impression on brick, then that is good quality brick. Size, shape and color test. In this test, randomly collected 20 bricks are stacked along lengthwise, weight-wise and height-wise, and then those are measured to know the variation of sizes as per standard. Bricks are closely viewed to check if its edges are sharp and straight and uniform in shape. A good quality brick should have bright and uniform color throughout. Soundness test. In this test, two bricks are held by both hands and struck with one another. If these bricks give clear metallic ringing sound and don't break, then those are good quality bricks. Structure test. The featured surface of the brick is examined. It should be homogeneous, compact and free from any defects. In this test, a brick is broken or a broken brick is collected and closely observed. If there are any flaws, cracks or holes present on that broken face, that is not good quality bricks. Thank you for watching this video.